Okay, we're going to talk about 11.3 day 2, which is circles. Right off the bat here, we have two formulas that you can put in your formula sheet. So area for a circle is pi r squared. Just to be clear in your formula sheet, remember we're writing these as equations, so area equals pi r squared for a circle. Circumference, please notice that this is not an A equals, this is circumference. It's a big C is equal to, and you can choose which one of these two formulas you would like to use. On the formula quiz, you'll be able to choose which one to write down, or you can write down both. But you should also know both of them is pi d, which is also equal to 2 pi r. So those are your formulas for today. We're going to go through just a few problems here, some of them a little simpler than others, but we'll start off right here. So circumference equals 21 pi. It wants us to know the radius and the area, so we need to know that that's what those variables stand for. So starting off with circumference, I know two formulas for that. I know pi d, or I know that circumference is 2 pi r, and based on those two formulas I can solve. What I want to look at here is the 21 pi. It doesn't matter which one I set it to, but I want to find the radius, so I'm going to set it to this one. So my 2 pi r is equal to my 21 pi. With a pi on both sides of the equation, I can cancel those out. So I have that 2r is equal to 21, divide both sides by 2, I'm going to get my radius equal to 10.5. So I know that my radius is 10.5. That is an exact answer. I'm going to try to leave things as exact answers unless it says otherwise. My area then comes from the radius, so my area formula is pi r squared, and once I know my radius I can solve for that, so I can do pi times the radius, which is 10.5 squared. I can square this right here, it'll give me an exact answer. It gives me 110.25. I still have that pi left for that exact answer there, so 110.25 pi is my area. If I want units on these, this one is just units, this one is units squared, so I can include those if I would like to. Number 2, use pi as 3.14. Now some of these problems, and you can see in number 3, use pi as 22/7, are going to tell you to use a version of pi, so you're not going to give those as exact answers, or you're going to give them as exact answers with those versions of pi. Okay, to find c to the nearest tenth, so this is the circumference to the nearest tenth when it's given a radius. So I'm going to use my circumference formula of 2 pi r and fill it in. It's 2 times, now I know what pi is, it's 3.14. So I'm going to fill that in, times my radius, which is 5.2 here. Type that into your calculator, and you get 32.656. And it wants it to the nearest tenth, so that means 1 decimal place. So this 5 says we're going to round that up for a final answer of 32.7 centimeters. Not centimeters squared, it is a circumference, so it's a distance. Last but not least here, find area when the diameter is 14 inches. So my area formula is pi r squared. So I can fill it in. Now I want my radius, so my radius here should be 7. We should be able to flip between those pretty easily. But if I fill this in, I'm filling in 22/7 for my pi. My radius is 7 and squared. Again, type that into your calculator there. When you solve that out, you get an exact answer of 154 inches squared are my units. Going on here, I'm going to go over 4 problems that are similar to what you have on your homework so that you can see them, and then you can use those to help you on your homework. So if 6 ounces of dough are needed to make an 8-inch pizza, how much dough will be needed to make a 16-inch pizza of the same thickness? Hint, compare the areas of the pizza tops. So what you need to understand is that if you have an 8-inch pizza, that's a diameter of 8 inches, and you have a 16-inch pizza, that's a diameter of 16 inches, this pizza is not double the size of that one. Okay, if you think about it, that's just saying how far across it is, but that doesn't mean the areas, which is what you would actually eat, of the pizzas are just double each other. So it hints, compare the area of the pizza tops, because we're talking about dough, and that's covering the whole thing, not just a linear unit. So we need to find the area here, which is pi r squared. So pi times the radius for this would be 4. And we need to find the area here. The radius for this would be 8, so pi times 8 squared. And once we have those areas, so this one is 16 pi and this one is 64 pi. You can do this a lot of different ways. You can simplify those however you want to do it, but essentially you can set up a proportion. So that's what I'm going to do. I'm going to say that 16 pi is covering, now they told us that there were 6 ounces of dough here, so I'm going to do 6 ounces, and it doesn't matter which one you put on top and bottom, but keep these the same. So we did the area over the ounces, so I'm going to do the area here over the ounces, which is what we want to know, so I'll leave that as just x. When I cross multiply to solve, I'm going to get 16 pi x equal to 6 times 64 I can do, and that's going to give me a total of 384 pi, because we still have that pi on there, so 64 pi times the 6 there. The pi's can cancel out on either side of the equation, which leaves me with just dividing by 16, and my x is going to come out to 24 then. Remember that this represented my amount of dough that's needed, so I want 24 ounces of dough. A similar problem here, talking about pumpkin pie mix. 1 can is going to be used to make a pizza pie of diameter 8 inches. If 2 cans are used, they want to know what is going to be the diameter of that pie. Again, this is not a linear thing compared to something that's going to cover an area, so we have to change this to area. So area equals pi, my radius for this one is 4 squared, and area equals pi, my radius for this one I don't know, so I'm going to leave it as r squared. And we've got the 1 can and the 2 cans. It's kind of like ounces here. You can just use them as cans. So I'm going to do the same thing. I'm going to find these areas. So this one is 16 pi. And again, pi r squared, we don't know that one. And I'm going to set these into a proportion here. So my 16 pi over my 1 can is equal to my area over here, pi r squared, over my 2 cans. And I can cross multiply and solve again. Cross multiply here, we get 32 pi. Cross multiply here, we get just pi r squared. 1 times anything is just itself. The pi's will cancel, so I have 32 equal to r squared, which means that r is going to be equal to the square root of 32. Now, this is a radius. We're looking for the diameter, so we have to remember that. But if we look back here, it said root 2 is approximately 1.414. We want to use that. So somehow our root 2 should come out of this. If I simplify this, this is a 16 times a 2. The square root of 16 is 4. We don't know the square root of 2. Okay, so now this is 4 times what they gave us up here, 1.414. If we multiply that out, we get an answer of 5.656. Now this has to find the diameter of the pie, whereas we have just found the radius down here, so we want to take that 5.656 and multiply by 2. And if we multiply by 2, we get an answer of 11.312. If we go back and look for units, we're looking in inches here for a final answer. Going on to the next one, something slightly different. A Ferris wheel has a diameter of 42 feet, so diameter is 42 feet. How far will a rider travel during a 4-minute ride if the wheel rotates once every 20 seconds? Now what that means is that if you have the wheel, it's going to go around and your bucket is going to make it all the way back to the starting point every 20 seconds that you go. So the first thing I'm going to do is talk about how many times are we going to actually go around the wheel here in a 4-minute ride. So if you have 4 minutes and you multiply by 60, that's going to take you to seconds, and that's going to give you 240 seconds that your ride lasts. Every 20 seconds, I'm going to divide this by 20 seconds. Those are going to go away. If we divide this, we're going to get that there's 12, and this is talking about the rotations. We're going to go through 12 rotations. Now, if you're talking about how far you're going to travel, you're talking about a distance, and the distance around a circle is a circumference. So we're going to find the circumference, and I'm going to do pi times d just because we were given a d. So that makes it pi times 42. They told us pi was going to be 22 over 7, so times 42 is going to give us 132 feet for one rotation. Now we have to bring this idea and this idea together, and we have to take 132 times 12, and that gives us 1,584 feet in those 12 rotations, or in those 4 minutes. Last problem here, and then you can work on your own. The figure at the right consists of semicircles within a circle. Find the area of each shaded region. So we have a semicircle here, and we want to find the area of each shaded region. So this is a little bit of a tricky one here. So I'm looking for the area of this shaded region out here, but if I look at it to find the area of just the part above what I drew, so up here, and I'll color it in. So the part that's green, I'm going to take the area of the big semicircle minus the area of what I'm going to call the medium semicircle. So the big semicircle is what I have out here. The medium semicircle is this one that's outlined by the white and then goes through here. Again, this is the medium one right here. If I subtract those, that's going to give me what I shaded in green. And then I just have to add on this part right here. So I'm going to add on the area of the small semicircle. And that will give me the area of each one of these shaded regions by itself. Now, you given the 2 here, there is a 2 here and a 2 here as well. So when we look at this, the big semicircle, and I'm going to do a semicircle, so my area is going to be of a circle would be pi r squared. For a semicircle, just do half of that. Okay, so for the big one, I'm going to do half times pi times my radius of the big one. Well, the diameter is 6 straight across, so the radius is 3. Minus the medium one, so 1/2 times pi r squared. My radius for the medium one, if I look at this again, there's my diameter of the medium one, which is 4. Half of that is 2 squared. And then plus the small one, 1/2 times pi times my radius of my small one, well, the diameter, and I can look right here, doesn't really matter. Diameter is 2, so the radius is 1 squared. And this is what I'm going to solve. So if I solve this out, now I'm going to have halves in all of these, so I'm not going to cancel them out because I'm adding and subtracting fractions in a second. So I'm going to get a 9 pi over 2 here minus a 4 pi over 2. Again, I'm not going to simplify that because I got to deal with these fractions. Plus, and then this is a 1 pi over 2. So to solve fractions, we just do the tops. So 9 pi minus 4 pi is 5 pi plus 1 pi gives us 6 pi over 2, and that simplifies to just 3 pi. We wanted the area of each shaded region, so this has an area of 3 pi units squared, and then the other one, this over here, has the area of 3 pi units squared as well, but it wanted each, so I'm not going to say 6 pi in this case. Okay, that should do it. Again, you have homework from the worksheet, and these are similar to some of those problems, so use that to help you.